All right, hello everyone. I wanted to go live today and basically try something new. I'm calling this Data Science in the News. So this is a LinkedIn live session where we're going to talk about a couple of articles that I read through earlier today about data science. So to be specific, there are 6 things I want to cover. We're going to talk about Stanford piloting a data science fellowship program, an article that says data science is not a science project, one around DataRobot becoming a unicorn by selling artificial intelligence toolkits to harried data scientists, an update on Intel's chief data scientist who's now an FBI advisor, how light saves kids from online toxicity using data science and artificial intelligence, and then lastly we'll talk about expert tips to help kickstart your career in data science. All right, so the way this is going to work is I'm going to briefly talk about the article, maybe read a couple of the quotes from the articles themselves. I will be sharing links to the articles if you want to get the full picture, but I'd love for this to be a discussion. So if you have feedback or anything that you want to talk about in terms of this article, I would love to hear from you in the comments. So let's go ahead and begin and talk about Stanford piloting a data science fellowship program. Basically, they have this thing called Data Science for Social Good, DSSG, and it's basically a 9-week program where we get paid. You can be an on-campus person, and it's basically like a summer opportunity that's open to all students, which I thought was really cool. It's not only open to students that are specializing in data science. So there's Ben Stenhag, who is a PhD student at Stanford, who is actually a mentor in the program. He says that it's sort of the opposite of a teacher giving you a really well-curated data set, then you're trying to run a model. Basically, instead of that, it's students that collaborate together with a project partner that has a need that they're trying to meet, and the students work to service that need. And usually those partners are companies that are striving for making a positive social impact. So, all right, I see a couple of people have joined, so I'm just gonna say hello. Nathaniel, Eric, Dev, thank you guys for joining. All right. Hello. It'll be great to also know where you're coming in from. So thanks, Tom, for asking that question. So Emily, who's Guthrie, who's participating in the program, so she's basically been doing this type of coursework, and she says that with her typical coursework, there's usually beautiful data sets and instructions of exactly what to do, when to do it, how to do it, and there's nothing that tells you like a real life situation, right? So she's saying in this case, they have to spend a lot of time cleaning messy data and thinking about a strategy with which to approach the problem. So it's not always obvious working with this real data, what decisions to make when you find that there's an error, or trying to figure out which modeling technique to use. So it seems like she's really getting a benefit from working in this program. So the other thing is students who are in this program are developing not only technical skills, but also team building and communication skills. Because at the end of this last week of the program, they have a final presentation to the partner of the organization. Now, I thought this was really cool. I'd love to hear from you. So do you think other colleges should be kind of trying to replicate and model after this type of program? Because I think it could potentially close the gap of students that are graduating from undergrad or grad school, and they've never really have worked on real data sets. They've been working with clean and fake data sets. So I think this would bridge that gap, and in addition to that, also impacts society, right? It has a positive impact on society because these are organizations that need help with data and data science, and this way you're not just going off on your own. You also have a mentor who knows what they're doing from a data science perspective that can guide you. Okay, let's move on to Data Science is not a science project. So this is written by Oliver as of September 27th. So let's go ahead. Basically, he starts off by talking about a survey that says that the vast majority of companies are investing in big data and artificial intelligence. He uses a really high number. I think he was using 97%. Not sure how accurate that number is, but basically I do agree that a majority of companies are investing in AI and analytics. He goes on to say that at least half of analytics results will never make it into production. So organizations have to move beyond this step of just gathering data. And you can hire data scientists, and what happens next is they create these models. So he also says that several models are created in this discovery phase of projects, but if they're not operationalized, then a company they can't drive the business outcomes, and basically the full potential of data science cannot be realized. Oliver says that if you, as a company, if you plan to invest in a data science program, you should be well past the hypothesis and data collection phase of the project. You need to have a clear problem identified that you already are ready to tackle with analytics, and you need to know where the data will come from or what data you would use. Now, let's take a minute, and I want to know, do you agree with Oliver? Because I would think companies, for the most part, would need a data scientist for parts of what he's said, basically figuring out which data to use, because business users typically are aware the data is being collected, but I don't think they're as able to understand if the data that they've collected is sufficient or where it's coming from. I think for the most part you would need a data scientist for that. He also lays out 3 steps of how to take your project from an idea to implementation. So he says, number 1, start small with a project that addresses a core competency of the business. Make sure all parties agree on the business value and technical feasibility of the project. I agree with that. Starting small is usually good. You can iterate and build it out as there's a need. Number 2, he says to select a project that will offer a win within a year. I do agree that time boxing it can basically show you if you're doing something right or wrong, right? And you can minimize the cost impact of it if you're trying to see a win within a year. He says know going into the project what a win looks like and how it will be measured. Yes, absolutely. Having a success criteria identified early on is key, because how do you know if you've done the right thing if you've never defined what the right thing is? Number 3, he says look for opportunities to automate and expand your use of analytics. Automation can multiply the results of your project exponentially. Yes, absolutely. Whenever I work with data in my company, I try to, as much as possible, automate all of the little steps that have to take place, because they do add up, right? If you say, oh no, this only takes me 20 minutes, I can do it, it's only once a week and it takes me 20 minutes, well, just think about how many minutes it ends up being in a year, right? How many hours, how many days of your life you're wasting doing these repetitive tasks that if you had automated them in the beginning, you would have had all this extra time. He also includes 2 really cool examples of successful data science implementation stories that you can go and read about in the article. I won't get into it here. Question here for you guys is, what would you add to his list of 3 things in terms of operationalizing data science? I think for me, the one key thing I would add is making sure that you really communicate with the business, like a lot, before starting to do any work, because if they're not bought into the idea and they're not going to use it, then there's really not much of a point to continue on with this work. All right, I see we've got some really interesting comments here. All right, Steven says, agreed, we should be working with real world data, raw and not pre-cleaned. Yes, Steven, I agree with you. I think it's just a little difficult for students when they do get some raw data. I think now it's easier to collect and get raw data, but they still need some guidance, right? Because they're not sure if they cleaned the data properly when they cleaned it, or if they've identified the right algorithm to use. So I think doing that as part of a school environment or with a mentor is a really good idea. All right. Okay, let's go on to the next article. This is a really interesting one. So DataRobot becomes a unicorn by selling AI toolkits to harried data scientists. Okay, this was published in Forbes, written by Jillian, September 17th. So DataRobot, right? They want to make machine learning so simple that a business analyst with basic training can run predictive models without breaking a sweat. That's what they're trying to do. So they try to automate as much of a traditional job of a data scientist as possible. The idea here is that customers come to the service with data and they have a business question, and the DataRobot system will turn around accurate models for a given task. So basically, they say that you don't need all the different personas, data engineers, data scientists, application developers, and others. They claim that a business analyst can do the whole thing themselves. So DataRobot abstracts the underlying complexity, so we can shrink the time of production and seeing value from what we could do in years into weeks. This is interesting. Now, the company has hundreds of enterprise clients, and to date, their customers have built upwards of 1.3 billion models using this platform. And Jeremy Atchen, the CEO, says that we're automating more and more of the process, and we have so many ideas for different markets and different products that it feels like there's an infinite roadmap ahead. Now, like I said, I thought this was a really interesting one. I'd like to know what you think about all of this automation. I'm assuming most people that have joined this live stream work with data or are data scientists or aspiring data scientists. Do you think it's possible to make things so simple? Are we going to be running into people, that have never used algorithms, who don't really understand statistics or programming or math? Do you think that we'll be running into issues with having them being able to use machine learning and basically with the click of a button as what they're trying to build? I do think we'll get to a place where people will be able to use these models more people will be able to use these models without much of an understanding. I don't think we're there yet, but I'd like to hear from you. The other thing I wanted to point out here is maybe we need to think about it differently, because we think of data science, machine learning, deep learning as this really complex black box. But what if we think about microwaves or cars, right? Most of us, I know I don't know how a microwave is really built with all the mechanics and stuff, and I don't know how to build a car or what all the little parts are. Maybe some of you will know, but I do know that I'm able to use, I don't use microwaves, but I know how to use one, and I've used one before, and I didn't really have to learn much about engineering to be able to go ahead and click a few buttons and we survived. So I thought that was interesting, because if we think about it differently, then yes, I think it is possible to have the layman use machine learning algorithms without really having to understand them. Eric says, with the businesses, it's not a problem to collect data. The issue is a good model to execute the problem. Yes. And Eric says, data collection for academics is quite difficult for academics than professionals. Thank you guys for chiming in there. All right, next up is Intel's chief data scientist is now an FBI advisor. All right, now I thought this is really cool. So Melvin Greer is serving as a fellow in residence and senior advisor of FBI's Information Technology Application and Data Division. So it's ITADD. And he's basically going to help the agency with its data management strategy. He's also going to keep his job at Intel, and I do remember seeing Melvin's name when LinkedIn's Data Science and Analytics Top Voices came out for 2018. I remember Melvin Greer's name was on that list, so it was pretty cool to see a familiar face in the news. And if you aren't already following Melvin, then I suggest you do. He puts out some interesting materials. Okay, this next article is about light saves kids from online toxicity using data science and artificial intelligence. Now, this is written by Sandra as of October 10th, 2019. Basically, with increased connectivity comes increased concerns, right? Especially for parents with children who have access to the internet, which in this case, I would think is most children who are of the age that can use an iPad or use the internet. There's a statistic here that says almost 40% of kids between ages 12 to 17 in the US have faced some form of online bullying. Now, that's almost half the kids. I think that's a pretty big deal. And 83% of young people would want to see social networks act against online bullying. I would think it's 100%, but you can never tell with survey data. It could get a little tricky. So, the CEO of the company, Zohar, says, I started Light because as a father, I suddenly became aware of the dangers my children were facing online and how these nefarious characters change their tactics continuously to stay under the radar. With the advent of deep learning, we have the ability to identify these conversations and predict something toxic is about to happen. So whether through text, audio, video, or image. So solutions to date have been really focused on consumer-oriented parental control applications. For example, I bought my kids an iPad, and then I think when I connected it to Amazon Prime, it said, you can turn on parent control, or on YouTube, you can control, what your kids watch. But unfortunately, that's not really 100% foolproof, because I've noticed sometimes that my kids will be looking at something that has a label of, hey, Barbie plays with water, and then I was watching what they were looking at, and I noticed that one of my daughters was watching a video of a Barbie being stabbed with a knife in a puddle of water. Now, the description may be slightly relevant, meaning the title of that video, but that is definitely not something I would want my kids to watch. So, we have to take greater efforts to try and control that. So Light takes a different approach. Basically, it has an end-to-end solution for popular apps and games that work directly with the social network or mainstream game as part of the infrastructure. So this is different, right? This way, for example, Minecraft would plug Light into their platform, and they'd be able to defend millions of kids at once. So we wouldn't have to tell parents, where in some cases parents might not be as tech savvy, and they might not even know what the kids are doing with their technology. So this eliminates that risk. So there are still challenges in eliminating all toxicity from the internet from the eyes of children, but basically Light is on a mission and they're not giving up. So I would like to know what your thoughts are on this, right? Do you think we are going in the right direction of trying to censor this generation? I do have kids of my own, and I love the idea of being able to protect them and reduce potential online bullying, or protect them from seeing graphic images that they're not suitable for minors. But at the same time, I do wonder if this is a little bit too much of that big brother type of technology, where we end up raising kids that are overly protected and are not really developed and ready for the real world, which is not a rainbows and butterflies place, unfortunately. Now, the last thing I'm going to talk about here it's called Expert Tips to Help Kickstart Your Career in Data Science. Basically, if you're thinking about a career in data science and you're not sure where to start, there's an article here that provides a few quick tips, and I'll go over a couple of them. So Steve Flinter says that you shouldn't underestimate the importance of understanding the domain that you're working in. So if you're working in if you're trying to get a job in a bank, then you should probably know what some of the biggest concerns are for the financial services industries. What are the banks worried about? What are some regulations that are impacting banks? Basically, get to know the domain that you're trying to work in. The answers are not always in the data, and speaking to experts in the field to understand how it works and how they make decisions, for example, is hugely important. Because very often, a lot of their implicit knowledge is never recorded anywhere, and it's not easy to discover from data alone. Now, I spoke about this a couple of days ago when we were talking about whether it's easier to train a person, like a citizen data scientist, like a person who's working in the business, teaching them programming and data science skills, or is it easier to teach a data scientist domain knowledge? A lot of people have commented on that post and said that it's easier to teach somebody in industry data science skills, and I tend to agree with that, because the data science skills are, for the most part, they're complicated and technical and they're difficult to learn. I understand that, but at least they're documented, right? I don't think there are many resources out there that say, here's a book on all things banking, or here's a book on this industry or that domain or this specific area, because things change so often that we kind of have to be experienced in them before we can actually learn them. And in the other sense, data science skills and technical knowledge that you have to build is documented for the most part. Now, Ian Lane, a senior consultant in advanced analytics at Dun & Bradstreet, says, learning to program in Python is certainly a huge help. I agree with you, Ian. I'm actually learning to program in Python as we speak. So she goes on to say that there are great courses on Udemy, as well as sites like Kaggle, where you can get access to data sets and enter data science competitions. And doing well in these competitions can get you noticed. So she says, get to coding. Steph Locke of LockData. Future-proofing your skills is key to ensuring a solid foundation. So her advice here is really to keep your finger on the pulse of newer techniques around like deep learning, reinforcement learning, because there's so many aspects that you have to work with, like working with unstructured data and video and images, and it just keeps getting more and more complex. And then she says, basically from the machine learning side, to have your business data, like the data everyone has about the tweets are performing, who your customers are, what your processes are doing. The data is here to stay, and that data is never going away, and it doesn't matter what industry you work in. So definitely keep your finger on the pulse of what's happening. Last but not least, we have Jennifer Cruz, Head of Data Science at Aon Center for Innovation and Analytics. So she's excited for what the future of the industry holds and what will it mean for insurance. So what she predicts as far as soft skills is that having a strong capacity for creative thinking will go a long way. Most important to her are people using creativity in how they approach the problem, but then fusing that creative thinking with logic and data science and machine learning. So I think people had some really good advice here. I'd like to hear from you what your advice is for aspiring data scientists. I think it's something I would add is working on a personal project. And I know they mentioned Kaggle, but that means you're using a data set that's already provided to you. If you feel strongly about a specific issue and you are able to go and collect data for that specific issue and analyze it, and kind of goes back to that social good article that we spoke about earlier, then I think that's really beneficial because you'll be, motivated to do the work and to learn as you go. So basically getting your hands dirty. And also practicing communication is a key skill, because if you can't describe it, it's really hard to operationalize it. So once you've completed that project, that personal project of yours where you got your hands dirty and you had a hypothesis and you knew what you wanted to get out of it, then you can go ahead and try to record a video of yourself presenting this to an audience. You can even publish it on social media or go live on LinkedIn, on Facebook, on YouTube, on wherever you want to do that, and get people's feedback. Send them a video and say, hey, I did this project, and it doesn't have to be long. It could be 3 to 5 minutes. Explain to them what you did, and I think with that, it will help you get some practice and improve your communication and presentation skills. So Graham says, hey Graham, it's about the way we work together, not teaching one person a new skill on either side. Yes, I agree. I guess you're referring to the data people and the domain people working together. So anyways, guys, thank you so much for joining and listening to Data Science in the News. I do wonder if you like this format. I can continue doing this every couple weeks as I read articles. I can just, take some notes on them like I did this time, and basically we can go on and have a conversation about it. All right, have a good rest of your day. Bye.